Hey, good evening once again, everyone. I trust you're doing well. Today marks session 24 of you're getting a very simplified introduction to robotics, and so far you've made some good progress. This week, from Saturday, Sunday, and today, what we have been taking a look at is the final stuff in programming. The final stuff you need to know about programming so that you can write some code onto microcontrollers like these Arduino boards and an ESP32 board like this one, right? The microcontrollers like this. And like we mentioned, very soon you're going to be designing your own board like this one. You're going to be designing a board like this or a board like this one. You're going to be working with these microcontrollers. But before you're able to work with microcontrollers, you need to learn how to write the instructions. Whenever you want to build a product with these microcontrollers, whenever you want to program them, there are just a few things. And today marks the last thing we are taking a look at. So do not have any do not be do not be at peace with yourself that you've taken a look at all of the things you need to know when you need to program a microcontroller like this for a product or for a project, right? So first we have, for every product, there are sensors attached to them, and those sensors generate data, right? And so we need to store those data. So that's why you took the first lesson on variables and data types, how to create a variable, a container that is going to be storing those data, right? In terms of temperature, so 24 degrees Celsius, 50 degrees Celsius, all of those data are going to be stored in that container, in that variable. All right. And then, yeah, data types. So to create that variable, you have to use the right data type. And after learning about data types and variables, you went on to make decisions because when a system has read information or data from its sensors, now there needs to be something like, okay, if the sensor gives us a value of 30, we want to do this. If the sensor gives us a value of 20, we want to turn it off. If it gives us a value of 50, we want to turn it on, something like that, right? So decision making. And that's why you learned conditional statements. And for conditional statements, you learned if else conditional statement and switch case conditional statement. So for switch case, that's when you have multiple conditions, and you can say in case the value is 30, in case the value is 20, we want you to do this. In case the value is 10, we want you to do this. In case the value is 100, we want you to do this, right? So you learned about conditional statements. So first, you learned about variables and data types so that you can store data from your sensors. And then you moved on to making decisions with the data that you have gotten. After getting some data, you need to make decisions. All right. And then after conditional statement, you moved onto what else did you take a look at? After conditional statement, you took a look at loops, right? Loops, which happened just this week. So loops is when you want to control the flow, right? The flow of the code. Even when you want to control the flow of code, conditional statement is part of it. So we have conditional statement and loops. So these two things are used to control the flow of code. But yeah, you took a look at conditional statements and then you took a look at loops. And for loops, you took a look at for loop, you took a look at while loop, and then do while loop. And I believe in our previous session you made good progress. And then after taking a look at loops, then you move on to functions, right? Functions, so built-in Arduino functions, and then your own functions that you can create. So in yesterday's session, you took a look at some of the built-in Arduino functions, and we did that using a very good strategy. And the strategy for learning was that there's no need memorizing everything about programming or everything about these built-in Arduino functions. All we have to do is just get the concept right, just get the classification or the categories of these built-in functions. So there are functions for timing, there are functions for controlling input output, there are functions for doing math, there are functions for functions for everything that you want to do, right? And so And so that was the very, very important thing you had to note. And so from today, if you want to work on any system and you need to use a function that will be calculating the square root of a number, or a function that will be adding or yeah, any project that you're working on. If you need a function that is going to do a certain task for you, a function that is going to control an input pin and output pin, all you have to do is now do targeted research, a research that is targeted at what you are building, and then you look at functions that you can use for it, and then you learn how to use that function, and that's it. So simple. Then you know how to use it. So it's not about knowing all of the things, because you cannot know everything. So that was a very good strategy we used. And yeah, so after learning about these Arduino built-in Arduino functions, specific keywords that the Arduino platform has created, so that you can use it to do some things. After taking a look at them, the timing ones, the ones that I use for timing, the ones that I use for math calculations, the ones that I use for controlling input output. After taking a look at all of these functions, we then learned how to create our own functions. And I think we missed something in yesterday's session. We're going to be going back and correcting that very, very quickly. But yeah, so that was functions in yesterday's session. Functions, your own functions that you can create. And for your creating your own functions, we had two things, right? We have two kinds or two types. And one is a function that is just going to do an action, a function that is just going to turn it, it's just going to be controlling an LED or a light. It's just going to be turning it on and off. And it's just going to be doing some controls without bringing us a value at the end, right? Without returning a value. A function is a piece of code that can be reused multiple times, right? It's just like say writing, you're a teacher and you want to help your students write myself, right? So all you have to do is just create a template for them. So you can just get a paper, like this, and then you can just get a paper like this, and then you write my name is dash. I come from dash. I am dash years old. That's it. You've created a template for them, and then you can now you can now tear the paper and then give it to every one of them, and then you let everyone, each of them, they all have different names. So someone may be called Samuel, another person Abdul Salam. We have Roddy here, we have Felix here, we have Bernard here. So now if I take it, I'm going to write my name and where the dash is. So functions are just our creating some piece of code that will be reused multiple times, right? So if we want to calculate we want to add sensor one to sensor two, we want to add the values that are coming from one sensor to another sensor, all we have to do is just create a function that is going to be taking the pin numbers and all of those things. But yeah, I believe you made some good progress. So after learning about loops, then you learned about functions in yesterday's session. And oh yeah, so for those functions we have two types: one that is not going to be returning any number after it has run, and then we have one that is going to be returning a number. So after doing the calculation and all of those things, it will get the answer, and then the final answer, and then put it in a variable. And then after the function runs, it brings the final answer it returns the final answer like a feedback. It gives you feedback at the end. But yeah, if you missed yesterday's session or you missed some important parts at the very end, you can we've posted that onto our YouTube database, and so you can just go refer to it, and then you can just watch it, and then you make some good progress. But yeah, so in today's session, after taking a look at functions in yesterday's session, in today's session, the last thing you need to know about programming. If you want to write code onto microcontrollers, the last thing you need to learn about is library. So that's it. So we have just our 5 things, right? So variables and data types, conditional statement, variables and data types, so that you can store data, right? You can store the data in containers. And then we have, after storing the data, you need to make decisions. So we learned about conditional statements, if, else, and switch case. And then after learning about conditional statements, you learn about loops. Loops, how to do something multiple times, like 5 times. When we use the example of a child going into a room and then finding about the mother put about 5 boxes there, and then so If you want, if you know that the definite amount of times that something is supposed to run, then you use a for loop, a while loop, or a do while loop. We understand them. So variables and data types to store data from sensors, conditional statements to make decisions, loops so that you can do certain things 5 times or 6 times, or you can say that, okay, while this thing is true, we should do all of those things. So that's loops. And then you learned about functions yesterday, so that's the fourth thing. Functions, when you want to create your own way of something happening, and you want to reuse those functions in multiple spaces in your code, that those are functions. And then built-in Arduino functions, if you want to read from sensors, use an analog read, keywords, digital write, digital read, pin mode, those things you need to know about them. And so you learned about that in yesterday's session. Those are functions. And then finally, the fifth thing is libraries. And so at the end of today's session, you should not refer to yourself as a beginner. No, you're not a beginner anymore, right? You're not a beginner anymore. From now, from very simple systems to complex systems. It's just these five things that engineers use when they want to build a product, when they want to write code onto microcontrollers to build products. No, it's just these five things: variables and data types, statements, loops, functions, and libraries. So by the end of today's session, you would have covered everything under programming. Now, after doing all of the programming stuff, these five things, then you now have to work on projects to get familiar with some of these things, and then how to apply them practically. So that's the only thing, and you have that figured out. It's going to come very, very soon. But yeah, let's focus on what you need to get done in today's session. What are libraries? So what are libraries? That's what we're taking a look at. But yeah, let's go straight into Arduino IDE, and I believe we can do some wonderful stuff in there. Let's go into Arduino IDE in here, and yeah, let's do a correction on what we mentioned. We missed out on in yesterday's session. All right, let's go off video, and I believe my Arduino IDE should share in a second. Okay, it says cannot share. All right, let's share my entire screen, and I believe that's going to solve the issue. Now I believe it should share. Once you can see my screen, please give me a thumbs up if you can see my screen. Okay, it says can't see my. Okay, it says I can't share my screen. All right, let's do this. Let's stop sharing entirely. Let's stop presenting, and now let's share again. Now it's going to work. Usually, these things are Google technical issues, but well, perhaps it may be ignorance on something that is not working, something we do not really know about that is happening. But yeah, I believe now we're able to see my screen. Give me a thumbs up if you can see my Arduino IDE open now. Today's session, libraries is a very it's so simple, and so we shouldn't spend so much time. Let's quickly do this. Ready? You gave me a thumbs down. I believe you can see my Arduino IDE here. I've selected all of the code. I believe you can see it. All right. So yeah, that was yesterday's session. Functions. Ready? You're unable to see my screen. Okay. Perhaps. Okay. All right. That's great. All right, you can see it. All right, great. So yeah, this was our session, yesterday's session, functions. All right, now remember in here when we were creating a function like int add numbers, right? This was the name of our function. We mentioned that there are certain things you write in here, the parameters. We forgot to give those parameters, those variables in here. These are variables. These are actually variables. But I think we used the explanation. These are just words that we mentioned. But yeah, so since these are variables, you need to give them data types, right? So if the function you are creating is going to be taking numbers like this one, right? It's going to be taking parameters number 1, number 2, number 3, right? You need to say, since those are going to be numbers, right? So if it's going to be whole numbers, then you can say int, right? So it's just say int number 1, And then so that's just the thing we didn't do in yesterday's session. So you just say int, right? That's it. So simple. So you just say int number one. So you create a variable, you get three variables in here. Right. So let's take that again. When you want to create a when you want to create a function, all you have to do is just write the name of your function. But even before you write the name of the function, if it's a function that is going to be returning something, if the function that is going to be returning an answer at the end of the function running, right? At the end of the function, the functions, at the end of the after the function has run, if it's supposed to return a feedback, you need to tell which type of feedback it's going to be sending, it's going to be bringing, whether the feedback is in terms of a number. If the feedback is in terms of a number, positive and negative whole numbers, that's integer. So all you have to just say, okay, integer, right? So integer, and then you write the name of your function here. And if this particular function here is going to be returning an answer in terms of a feedback in terms of decimals, then you can say float, right? You can take int here and say float, and that's it. You put the name of your function here, and you say add numbers. That's it. But since our function that we are creating here, we're going to be putting the parameters that we're going to be putting in here. We're saying that the name of the function is add numbers, and it's just going to be adding numbers, right? So the name of the parameters in here are just whole numbers. So we're just going to say int number one, int number two, int number three, right? So these are three variables, three parameters that we're going to be expecting a user to enter into the function in order for the function to do something for them. All right. So yeah, so that's it. After doing that, bracket open, bracket close. After bringing the name of our function, we bring bracket open, bracket close, and we bring curly bracket open, curly bracket close. And then in here, we write what the function is supposed to do. So we just create another variable to store this particular action that we've written here. So we are saying number one plus number two plus number three. So now, after creating our function, we can just call our function in here and then say add numbers, right? Add numbers. This is the name of our function. So you want to call a function, all you have to do is just come here and then say add numbers, and then we bring bracket open and bracket close. And then just as we put int number one, int number two, int number three here as the parameters that will be going into the function so that the function will work on them. Then now we can put those numbers in here, 4, 8, 15. So the 4 here represents the int number one. So the 4 is going to be going, is going to be is going to go into the variable called int number one, right? And then we have a comma here. So the same here, comma, and we have 8, right? So the second number here, 8, is going to be going into int number two, this variable here. And then after it has received all of these numbers, then it comes into the actual function, right? And then it says that wherever it sees number one, right? So 4 goes into number one. And then now it puts 4 here, 4 plus 8 plus 15, right? And then that's it. It's going to calculate and then give an answer of 27. So 4 plus 8 is 12. 12 plus 15 is 27. So it's just going to be returning the answer 27. And don't forget, answer here is just a variable that we created here. We said int answer is equal to add number one plus number two plus number three. So after adding, we'll just put the answer 27 in here in a variable. So now at the end, we just say return answer. That's it. And then when we want the function to run, we just write the name of the function here, and we'll put the actual parameters in here, and then we'll bring a semicolon. That's it. So simple, right? So simple. And then the return number, for that return number, we can print it onto a screen so that the user is able to see it. So we just see serial.print or serial.print ln, right? Serial.print or serial.print ln. And then we just print the return value, which is answer. But yeah, like we mentioned, sometimes when you hear something on the first time, second time, it may not really be clear. But as you progress further, as you hear it more and more often, and you're using it in a project, you're going to be appreciating this so well. Do not think this is so difficult. It's not difficult at all. But yeah, we just change this into int, yeah, and then that's it. Yeah, and then in here also for this function that we created, we said void turn on and off. So for the pin number that we wrote here, and then for duration that we wrote here, if the pin number is just going to be a number, we just say int, and then so it's like creating a variable, right? The parameters, it's like creating a variable, right? So we don't just write those words in there. We give the words a data type. So we say int duration. All right, that's it. And then to call this particular function here that we created, turn on and off, all you have to do is just come to your void setup part or your void loop part, depending on what you want to call your function, whether in a void loop part or in a void setup part. When you come, you just write the name of your function, turn on and off, and then you put the parameters in here, 2 and then 1000. So in this case, 2 is the pin number, right? And then the 1000 here is the second parameter here, int duration. So 3 is going to get stored in pin number, and 1000 is going to get stored in duration. And then in the loop here, those numbers that we've written here, 2 and 1000, those are going to be going into the names here, the variables here. So here is going to be 2, here is going to be 1000, here is going to be 2, here is going to be 1000. I want to believe that at least, even if it's not 100% understanding functions, you at least appreciate it a little bit. Give me a thumbs up if you appreciate functions a little bit now. Give me a thumbs up if you appreciate functions a little bit. All right, Bernard, that's great. Samuel, that's great. Isaac, all right, that's great. Isaac, that's great. Felix, I believe you're also great. All right, Felix, you're good. All right, all right. But yeah, once we go into our practical sessions, ready from porn. All right, that's great. So once we go into our practical sessions where we are building our own projects, these things, they are so simple. You're going to figure them out. So simple. All right, now let's go straight into libraries. So the question is, what are libraries? What are libraries? That's the question. So let's take everything here off. Let's take everything here off and let's put some synopsis here. What we're going to be doing in today's session. All right. Okay, let's go into video. And what are we going to be doing in today's session? Let's create our parts, right? So we have void setup, part of our code. So void setup, bracket open, bracket close, and then we bring curly bracket open, curly bracket close. All right, and then we come down here, and then we say void loop. All right, void loop. And we bring bracket open, bracket close, and then we bring bracket curly bracket open, curly bracket close, and then we bring spaces. All right, and then up here, universal stuff, right? So when we create a variable here, it's going to get seen both in the setup part and the loop part. All right, that's great. So simple. All right, now let's write a comment up here. So to write a very long comment, we just bring forward slash, and then we bring an asterisk symbol, and that's going to create those things there. And we just bring a space there, and then we can write a whole lot of important things here. So if we are working in a team, if Abdul Salami are working together with Bernard, together with Rodi, together with Felix, together with Isaac, everyone in here, you're working together as a team, you can put some information here so that someone who, all team members are able to know what exactly this particular code is, right? It looks like we have a hand raised. Bernard, do you have a question? Do you have a question, Bernard?
Hello, sir. Please, if you don't bring that slash star over there, are we not able to write any other comments apart from the coding?
Can you come again with your question?
The slash star that you put up there before, you said something about writing a long comment.
Yes.
Do we have to bring it so that we can then write a sentence apart from the normal coding that we'll be doing?
Yes, if I'm getting you right, so if you want to, for a very simple comment, right? For a very simple comment, just a line of comment. If you want to write just a line of comment, you can just use these two forward slashes, and then you can write something like this. You can write something like you know, when you do an action here, and then you say, okay, pin mode, right? Pin mode, pin 2, we're going to be using pin 2 as an output pin, right? Um, let's use that. So for this particular code that you've written here, if you want other team members to know exactly what you've done here, you can just put two forward slashes, right? And then you just write a very short comment. So these are used for very short comments, right? Just for two forward slashes. And then you can write here, Roddy, you can write something here like this. Roddy, here we chose the pen to be used for output. That's it. So simple. But let's assume you want to create. So that's it. Very short one. But let's assume this is you're working together as a team, right? And you're going to be presenting this your projects to an entire school, and they want you. And when you're building a project, usually, when people are writing books, you're going to find that, especially when those publications or those books was put together by about four people, about four lecturers, or about four, yeah, just about four people or four professors that have written a book. You're going to find that they first write something, right? Something here, and then they say, okay, this book was this book came about, just write the authors, right? Authors. So they are going to write, if 7 authors wrote the book: Bernard, Abdul Salam, all of you, Isaac, Felix, everyone in here, Roddy. You just write Roddy, like team members, Roddy, Bernard, everyone in here, right? So you write the authors or team members. So if you want to write something like that, it's very long, or even a paragraph, very long, like a preface. When you buy a book, and I say my appreciation to my professors that helped me do this, all of those things. Those are very long comments, and so for those long comments, you have to bring your forward slash, and then you bring the asterisk symbol, right? And then immediately you do that in the Arduino IDE, when you make mistakes, it's going to tell you, right? It's going to show that it's a mistake. And then sometimes when you're writing something and it knows this is what you're writing, it will quickly do it for you, right? And so I didn't have to write the entire thing. I just did forward slash and then brought the first asterisk symbol, and then it completed everything for me, right? It just brought the other side of it. But if it had not brought the other side of it, I would have manually typed in another star, right, like this. I would have manually. So let's take, for instance, I take this thing off. I would have manually brought it. Everything down here is going to be assumed as it's like a container. Here's the top part, right? And then you need an end part. You need an end part for it to see that, okay, this is the end part, right? So this is the first part. This is the opening, right? So now we need to bring the closing. The closing, you just have to bring another asterisk symbol, and you bring a forward slash, right? So I believe now you can see that all of the colors in here have gotten back to it. So it's saying that just things in here are the comments. So in here you can write team members. You can say team. You can say this. You can say um this is a project called let's use that blinds, automated blinds, or a wireless controlled blind system, right? So this is a project called a wireless control window blind system. So simple. And then you can put authors or team members. So team members include include Bernard, include Bernard, Felix, Isaac. This is very long. And then you can say our appreciation to all students who contributed. You can write a very long, like an essay. You can even write a full essay in here, just because you brought the end, the opening of the comment, and then the closing of the comment, right? The opening of the comment and then the closing. So this particular one is used when you want to write a very long comment. But for a very short comment, all you have to do is just bring 2 forward slashes, and that's it. That's your. So you do not need you do not need to bring any ending part. All you have to do is just it's a single line, right? After this two forward slashes, everything in here is a comment. I do not know if I've quite answered if I've quite answered your question, Bernard.
Yes,
Is
sir, I
it?
understand.
Oh, okay. All right. All right. Since it's a bit good, I think we can proceed. All right. So what are we taking a look at in today's session? Let's do this very, very quickly. So in today's session, we're taking a look at libraries. 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 All right. So what are libraries? First, let's consider libraries. And I think we did a little bit of an introduction in yesterday's session. We mentioned that libraries, they are just like functions, but they are libraries are like very long ones, a very big file. But functions are just things that we create in the code, right? But libraries are external files. They are files on their own, right? So you just go onto your web browser, and then you type in and libraries make work easier, right? So if you are working with a component like this module, like we mentioned, companies produce these components, right? If a company produces this particular component here, there's a real-time clock. And I believe those of you who have worked who have Arduino kits, these normal Arduino kits, you've seen this before. There's a real-time clock. This is just a module. And this module, I believe it requires that I believe it's going to require that you have a library to control it. And um, something like a servo motor like this one that is going to be turning to angles, right? It's going to be moving to it's going to be turning to an angle of 90 degrees, 180 degrees, depending on which angle you want it to move to. And other components. There's a very basic, a very it's a very small stepper motor, and it requires that you use a library, a specific library that you can use it to control this. Now, what is a library? What is a library? Let's go into what is a library. So you can find that you know there are so many companies, car companies, right? And like Kantanka and so many other companies. And you're going to find that when you want to build a car, there are several parts of a car, right? We have the chassis of the car, we have the tires, we have the tires of the car, we have the window, right? We have the glass that is the glass that is on the the door handles, the door of the car, right? There's glass there. And even on the windshield, is it windshield? Yeah. So there's glass, on the car, where the driver sits, and the yeah. So there's that glass. So and there's also an engine. There's an engine. So if you want to build a car, you want to start a car company and want to build cars for people to use, you don't have to build your own glass. You don't have to build your own tires. You don't have to build your own engine. All you have to do is just, there are engines that have been produced on the market, engines that are already working, engines that are already perfect, right? All you have to do is just buy the right type of engine, the right size of engine for the car you're designing, right? So you just buy the engine, and then that's it. You look at other parts of other things that are very, very important on the car. For example, you want to come up with a very, a new design or a new model of a car. All you have to do is just create, the shape of it and all of those things. And you don't have to engineer your own tires. There are tires on the market. If you're a car company, you do not have to build your own tires, because there are companies that manufacture tires, right? There are companies that manufacture tires of cars. So all you have to do is just say, okay, if the car is a big car, you just order for the size, that actual size of the size of the tires that you want, and that's it. They just bring it to you. They just bring the engine to you. And another one is the glass, right? So if you're a car company, you do not have to build your glass from scratch. Otherwise, you have to go for sand. And we know glass is made from sand, from silicon, sand, and then you make your own glass, and then you have to put an entire assembly line, an entire production line to manufacture glass. Have lots of machines, doing the glass. No, you don't do that. So if you want to start a company that manufactures cars, And even if it's an electric car, you don't have to build your own battery. So that's the idea behind libraries. You don't have to build your own battery, right? If you are building a system for people to use, all you have to do is just buy something like a power bank. Let's go off video and let's get this quickly. Good. I think we're back. So if you want to start a company that produces, this particular product that we mentioned, a product that a remote controlled blind system. So you press the remote and then it moves up, you press it and then it comes down. If you want to build a system like that for people to use, you don't have to build your own batteries. These lithium ion batteries. These lithium ion batteries. I believe everyone appreciates this. This is the same battery that is found in our in our laptops. Yeah, I believe for this battery, everyone appreciates it. So you just have to order so many of them, and then that's it. You assemble them. If you need, I think there's the nominal voltage for this is 4.2 volts, but usually we mention it as 3.7 volts. So if your battery needs to be let's say 12 volts, I think you can just add about three of them. Will three of them be okay? I think four of them will give you something around let's say let's assume 4 volts. So 4 for 16, right? So this is going to give you 16 volts. So if the system you're going to be building is going to be requiring a 16 volts battery, you don't have to start a company that produces batteries like this. You don't have to buy manganese. You don't have to buy lithium, raw lithium material. You don't have to buy the metallic. What metal is this? Stainless steel, or steel. You don't have to buy steel. You don't have to buy the blue cover and then put it on it. You don't have to re-engineer. You don't have to build the battery from scratch. No, you have to focus on the very important stuff, because these things have already been produced for you, right? So all you have to do is just buy batteries from companies, and that's it. So simple. And then you assemble it in your car. You buy good batteries and you assemble it in your car. And even we have shock absorbers, right? If you're a mechanic here, if you've done a little bit of mechanics, you know these things. And yeah, you just buy those things. You don't build a tire from scratch. You don't buy raw rubber and then process it and then you do all of those things. No, you are going to waste time. You don't build your own tire rims. Is it called rims? Rims. I think rims. Yeah. So or frames of something. Yeah. So you don't come up with your own car tire rims, right? So otherwise you're just going to be wasting time, right? So the important stuff is just the design of the car, some of the things that you want to pay attention to, some of the key details of your car. Those are the actual things that you need to pay attention to. So libraries are just like you starting. You want to build cars for people. So all you have to do is you don't have to build your own steer, right? You don't have to come up with a new steer design. It's not so important. However, if it's a special feature that you want your car to have, then you can tell your engineers to focus so much on it. But there are some things that are just default. There are some things that are just normal stuff. There are some things that are just normal. So you just buy your tires, that's it, and then you just attach it to your car. You just buy an engine and then you put it in your car. If it's an electric car and then you're going to be using batteries, you don't have to build a company. You don't have to start manufacturing batteries and doing all of those calculations to see, okay, when you add lithium to iron, what is the reaction that is going to be happening? You're going to be wasting so much time on doing this. So that's libraries. So you get your battery, you get the tires, you get the engines, you get the glass, you get the steer, you get the shock absorbers, you get all the other components, and that's it. And then you focus on the model of the car, the design of the car, how you want the car to be, how you want the car to sound, all of those things. And then you focus on those things. So those are libraries. So whenever you're working with a component like this RTC module, whenever you are building a project and you're working with an RTC module, there's a real-time clock module. It helps you get time, right? If you want to attach a module like this to your project, or if you want to use a servo motor, there are libraries that have been created to make our work easier. to make the work of engineers easier. Otherwise, you're going to be writing a whole lot of code to just do something very, very little. But what people have done, what other engineers have done is they have come up with they've already written the code for you. They've already put up code for you in a file. And then all you have to do is just download the file and then include it in your project, in your code here. So you can see you're going to find something like this. So in a typical code, if you want to control a servo motor like this using a library, right? You're going to find something like hash include, right? You're going to find something like hash include, and then the name of the library. So there's something like a less than symbol, and then there'll be something like servo.h, right? And then there'll be something like another but yeah, I think we can do a little bit of a confirmation, but this is just how a library looks like, right? So we just have to say, okay, I think we can do this. So let me just take this off. When you want to add a library, you just go to file, and then is it file? Go to is it okay, sketch? Yeah, and then you see let's see, include library. Yeah, and then you can just click on any library. Let's see one a library for controlling a servo, which makes our work easier. So we just click on that, and then we see up here, we see has appeared so quickly, right? So hash include servo.h. So that's it. That's just a library, and this is going to just simplify our working with this particular component, right? So there are so many other components that they are going to find, and whenever you're working whenever you're working on a project or a product, and you're going to be using certain components, and those components were produced by certain companies, right? Like this NRF model. These are wireless communication models. This one here, I believe everyone is able to see it. This is a wireless. This is called an NRF. It's called an NRF 24L01. I have about 4 of them here. So these are wireless. These are these are RF radio frequency modules, right? And then all you have to do is just put one. All you have to do is just put one on a microcontroller like this one. If you have an Arduino board like this one, you just have to attach one. You just have to connect it to one, and then you connect the other one to another Arduino board like this, right? So you have 2 of them, and then now you can send data from this one wirelessly onto this one. So that's it. That's what this particular component is. This is an NRF model, and to use this particular NRF model, this was produced by a certain company, right? And that particular company may write some code that makes the working with this very, very easier, very, very easy, right? So so that's a library. So now let's ask ourselves. So yeah, if you want to work with components like this, like wireless control, wireless communication models, or temperature sensors. Sensors also require that you use libraries. And so sensors, like a temperature sensor, a distance sensor, and other, and other components like a stepper motor. If you're working with a stepper motor, a servo motor, these other components, an IMU, an inertial measurement unit. It helps you measure the orientation of something. X-axis, how Z-axis, an accelerator, it has accelerometer in it. It helps you see whether the thing is that the product is accelerating. All of those things. So whenever you're working with electronic components, so many components like a temperature sensor, a wireless control module, and all of these electronic components, you have to use libraries, and libraries make your work easier. So it's just like past questions. In high school, we had past questions. Whenever a teacher wanted to set questions for students to do, all he had to do, he didn't have to sit down all day and then come up with new questions, right? He didn't have to sit down all day and then waste his mental power, waste lots of time coming up with original questions, right? All he had to do is just get a past questions book, You just get a past questions book, and then there are so many questions in it, and then he just pick some of those questions, and then he just perhaps make just a few changes, right? And then he uses it. So that's library. So if you want to build a car, you don't have to manufacture your own tires. You don't have to manufacture your own engine. You don't have to manufacture your own windscreen or light. You don't have to manufacture your own steer. You don't have to manufacture your own battery if it's a battery powered car. So all you have to do is just buy these components, put them together, and then that's it. And then you focus on the very, very important stuff, how your car is going to work, all of these things. So that's it. So simple. So those are libraries. Whenever you're building a project and you need to add this particular component to that component, you need to add a wireless control module, you need to add a temperature sensor, you need to add an audio sensor, a microphone, you need to add a stepper motor to control actuators. Whenever you want to add multiple components, those components have something that have been created to make the work of engineers so simple, right? So you just have to install, right? You just have to download and then install that particular library, and then you can include it like how we've done here. You can just add it into your code, and that's it. It makes your work easier. And then now let's take a look at the parts, right? The things that are found in a library. What are the things found in a library? In a library, we know that a library is just a file, right? It's just a file. And I think before we even take a look at the things found in a library, how do we get a library into our project? Just like this one, we saw that we just went on to Sketch, and we came to this particular part here, include library, and then we just clicked on it, and then we have lots of components here. So if you are working with an EEPROM, and I believe everyone in here, you know what an EEPROM is. EEPROM is just is it electrically erasable programmable read-only memory. So it's just it's just a chip. It's just a chip, an integrated circuit that you can add into your project, and it helps you store data, right? It helps you store just data, right? So that's it. That's an EEPROM. So if you want to use a chip like that in your project, and you need to program that EEPROM, right? You need to connect. You need to help the EEPROM communicate with a with your microcontroller. If you choose to write your own code, you're going to write a whole lot of code, like from top to bottom, a whole lot of code. But these libraries, they are already files, and then they have code in them, and those codes help simplify your work. It helps simplify your own work, and it makes you faster, right? So you just have to download this particular library, and then there are functions in the library. So that's the part of a library. There are functions in a library, and those functions can be the keywords in a library that will help you be able to use the library. So if you are working with a servo motor like this, and you want it to move forward to 90 degrees and back to, let's say, negative 20 degrees, all you have to do is just use the specific keywords found in the library. So now that we have, let's take this library off. Now that we have this servo motor library in here, we want to control the servo, right? There's going to be specific keywords or functions, right, in the library, in that particular file, that will help you, that will help simplify the work, turning this servo motor clockwise and anti-clockwise, right? So there may be functions like let's write that. There may be functions like servo. Okay, so let's do this. The first thing, when you're using a library, you first have to include the library into your code, right? So we can write a comment here. So we can say include your library. So first, if you want to use the library in here, you need to include the library by saying #include, and that's it, right? How it's supposed to be done. And usually, a library, you go to places like GitHub. Let's do this. You go to a place like GitHub, and then you find a library, and then it's going to give you examples so that you're able to see how it's used, how it's done, right? So it's not so difficult. It's nothing. You don't need to know about every library in the world. It's not even possible. So whenever you're working on a project and then you need to control a servo motor, you need to control a servo motor, then you just do a search and then find some libraries that will help you control a servo motor easily. Otherwise, you'd have to personally write a lot of code to just control this small thing, and then that will make you not fast, right? That will make you just spend just a whole lot of time doing something that is not important. It's like you want to build a car, and then you spend a whole lot of time trying to build a battery, right? You're going to spend 5 years, 10 years trying to come up with a very good battery, with an even good battery, and then you need to go through lots of certifications, lots of certifications to prove that this battery is good, right? So in order to just in order to just avoid all of the waste of time, all you have to do is just buy the battery and use it. So that's the same thing. We just download the library, we put it in here, and then we look into the library, and there are functions in the library. There are keywords in the library. So if you want to turn a light on, there may be a keyword in there that says that write something like turn light on and then put the number in there. That's it. And then it turns it on for us. So libraries make our work easier. Yeah, so whenever you want to use a library like this one, first you need to include the library. You need to put it up here. You don't need to put it in the setup part. You don't need to put it in the loop part. No, you put it up here. Like we mentioned, whenever you put something up here, it gets recognized both by the setup part and the loop part, right? So yeah, let's take this thing off. Let's take that example off. Okay, so you have to include the library up there. So you just say hash include, and then yeah, that's you have included the library. And then now you go into the setup part. Like we mentioned, in the setup part, that's where we set things up. So now you need to start the library, right? So you can say something like for this one, you can say something like no, that's the third step. Beginning or initializing the library. That's the third step. The first step is adding your library, and the second step is creating an object. That's the second step. So what's the meaning of creating an object? The meaning of when we say creating an object, it's just like giving the servo motor a name, right? It's just like giving the servo motor a name. So you may have about 5 servo motors or about 10 servo motors that are using in a particular system, right? But yeah, so all you have to say, okay, there's one servo motor that is going to be used on the x-axis. There's one servo motor that is going to be used on the y-axis. There's one servo motor that is going to be used on the z-axis. If you are building a system like that, so you need to create object. And object is just giving your component a name, right? That's it. So you just have to write something like servo, right? Servo, and then you put the name, the specific name that you want to give to your servo. You just give it to it. So you can say x servo, right? You can just say x servo. All right. You can just say x-axis servo, right? So yeah, x-axis servo. That's it. So simple. Or you can say servo 1. So yeah, you can just say servo 1, servo 1, right? Oh, okay, let's put an R here, servo 1. And then you put you put your semicolon. That's it. So that's just creating an object. So for this particular one here, the name here that you give, it's going to come from you yourself, right? That's the specific name you are giving to that particular servo you are going to be working with. You give it a name. That's what we mentioned when you say creating an object. Very, very simply, right? But the thing here that we say servo, it's just how things are done using the library. So when you download a library, we're going to be taking a look at it. When you download a library, it's going to give you examples of how to do it, right? So it's going to tell you that to create a specific object, like if you have 10 servos in your system and there's one servo called first servo, right? All you have to do is just write servo. All you have to do is just write servo and then save and then give it a name, right? So that's what we mean by creating an object. So you just say first servo, That's it. So simple. And then you have created your object. So the second step is create your object, right? Create your object. I believe we're all good. And then finally, the third step is just oh, we can write that here. Yeah, we write that up here. So we include the library, and then we create a servo. We create an object, right? We create an object. That's it. And the object can be, if there are multiple components that you are using in the system, and you are using the same library, you need to give those different components different names. So that's it. So this is one of the objects, right? So you just give it, you say, okay, this particular sensor, this particular object is just the first one, and then you go with another one. This particular object is the second one. That's it. So you just give it names, and that's what we mean by create an object. So you add your library by saying hash include, and then you create an object. You give it a name, and then on the third step is coming into the setup part, and then initializing the library. So you come into the setup part, and then you say something like first servo. So if you are initializing the library, you have to use the name of the library that you created. Remember, we created an object, right? We give the object, the particular component, a name, right? So we said this is the first servo that we have connected. And we'll do that by saying using the specific keyword that is used in the library. So in the library, they may tell you that, hey, if you want to create an object, start with the word servo, and then write your specific name that you want to give it. Right. So that's it. That's it. So simple. So we say servo, first servo. That's the name we give. So when you want to initialize the library, you want to start using the library, you want to set the library up, all you have to do is just write the name that you give to your object, just write it here. So it's just say first servo dot begin. Is this right? I think it's servo.begin. Let's see, is that right? First servo.begin. Let's go into Copilot. Let's see. I think that's right. So you just say first servo.begin, and then that's it. You bring your you bring your bracket open, bracket close, and you bring a semicolon, right? That's it. So simple. You don't waste time. You don't waste time memorizing stuff. Well, sometimes it's good, but you don't waste time storing so many things in your head when you can look it up, right? So you only have to know the concept, how these things work. That's the very important thing. And then when you're doing something, and then you need to clarify, you need to just do a little bit of a confirmation, just do just a quick search, and you figure it out. But yeah, so that's it. The third step is initialize the library, or start the library. So you just use the name that you give, and then you say first servo dot begin, right? And that's it. I am not sure what we are doing is right. Let's quickly take a look at let's consult a Copilot, and let's see if what we're doing is right. All right, let's go into a new tab here. Let's go into a new tab. All right, let's go into a new tab here, and let's see how okay, how do you initialize? Let's just type it in here. How do you initialize a servo library in Arduino? Yeah, and let's just click on enter, and then let's click on search here, and then Copilot will be able to just quickly give us a run through. All right, so the first thing is just include the servo library, right? So we just say include servo.h. That's it. So simple. And then we create a servo object, right? We create a servo object. So say servo, and then we give it a name. We just give it a name. So for this particular for this particular example that Copilot is giving us, Copilot gave it a name of my servo. That's it. And then the third step, okay, it says attach the servo to a pen, right? Using a function. And like we mentioned, there are functions in a library. But yeah, so in a setup part, he says Copilot says attach the servo to a pen. So we're going to assign a pen number to it. All right. Let's see. We need to for all right. So for this particular servo library, there's nothing like let's see if there's going to be something like servo.begin. So let's ask, that's what most some libraries would require that you start the library before you are able to use it. And so let's see, um do you do we write something like servo dot begin to initialize the library. Yeah, so let's just type in that, and then let's see what Copilot is going to be giving us. So in the Arduino servo library, you do not use servo.begin to initialize a servo object. Okay, so that's what it's saying, that for this particular library, every library has rules how you do stuff, but there are some libraries that require that you write something like the library.begin to initialize or start the library. But yeah, so I think we are done with the confirmation. We can go back into our Arduino IDE, and let's make some progress. All right. So we don't have to do anything like this, but for certain components like this wireless module here, you have to if there needs to be a communication using you if there needs to be I squared C communication protocol, you need to write something like wire. You need to write something like wire dot begin, and then you bring your bracket open, bracket close, and then you bring a semicolon. So you need to write something like this, right? But this particular servo library is different. So all we have to do is just include it into our code, and then create an object, give it just a name, and then in the setup part we can tell using a function in the library. And a library has lots of functions, like you mentioned, lots of keywords, how things are done. And so all we have to do is just say how to use that particular function in the library. It says write something like servo, right? So you just write the name of your servo, right? And then you say first servo. So we gave it a name of first servo. We created an object called first servo. So you just say first servo dot attach, and then we bring our bracket open, bracket close, and then we'll put the pin number in there. The pin number where our servo motor has been connected to. So if on our Arduino board, our servo motor has been connected to its signal pin. Signal is the orange wire, right? So its signal pin has been connected to pin, let's say pin 10. Pin 10 on the Arduino board. All we have to do is just put the pin 10 in here. So we all we have to do is just say 10. You just have to write 10 in here, and we bring our semicolon. So that's it, right? So the first thing is include the library, create an object, just give it a special name, like first servo, and then you come in and say first servo has been attached to pin 10, right? So the attach here, attach pin 10, is a function that has been created in the library file, right? Just as we learned how to create a function. So all you have to do is just give it a name, and then you tell it the parameter that it's going to be accepted, right? So yeah, there's the function that is found in the library. So I believe you've made some good progress. For every library, there are functions in there. There are functions in the library that tells you how to use it, how to do it. So if you're building a car and you're going to be using a tire, you're going to be buying a tire from someone, or you're going to be buying a dashboard from someone, or a battery from someone, the manufacturers of those battery are going to tell you that, okay, for this particular battery, you need a cooling system, right? You need a fan on the battery that is going to be cooling it down. Or, you need to do things this way, you need to do things that way using our battery. So it's the same thing in here. So the library requires that you use the function called attach, a keyword called attach, right? To attach the pin number on your microcontroller to it. And then now we can go into the loop part. We can write the instructions to make the servo move to 90 degrees, or to 60 degrees, or that. So all we have to do is just say first servo. What do you have to write? Let's see. Let's go into code. I think we'll have to write first servo dot write, and then we'll put the signal in there. So yeah, when you're working with a function, when you're working with a library, there are functions in the library. So all you have to do is just all you have to do is just learn more about the library, and then you know that the number of functions in the library, and then how to use those functions. But yeah, for this particular server one, you can go into Copilot, and then let's see how it's turning it. So it's saying, so Copilot is saying my servo.write 90 degrees, right? My servo.write 0 degrees. So it's the same way. We can just come back into Arduino IDE, and then to turn this servo, we just use the special name that we gave it, right? The object that we gave it. Yeah, and we say first servo, first servo, first servo dot write. So it's just like saying digital write or digital, analog write, like something like that. So just say first servo dot write. So it means we are writing a certain angle onto the first servo that we have created, that we have attached to Pen 10, right? So we just say first servo dot write, and it will bring bracket open, bracket close, and I will put how many, what is the degree one. So or the extent of the angle, right? So we can say 90 degrees. So we put 90 in here, and then we'll put we bring a semicolon. So the first thing is you plug your microcontroller into your computer, and then you connect your servo motor to pin 10 of your microcontroller, and then that's it. You're done. Now you need to just find a library that will help you simplify your code. If you're not going to be using a library like this, using the library, you just write just something like this, first servo dot write, and then that's it. You can turn your servo to the left or to the right. But if you're not going to be using this servo, you're going to write a whole lot of code in here. You're going to write a lot of code. You're just going to write a lot of code, a lot of loops to just do something as simple as this. Just do something simple as this. First of all, to just turn the servo to 90 degrees, you're going to write a whole lot of code in order to do it. But using a library, it makes it simpler for engineers, right? It makes it very, very simple for us. So that's it. That's a library. Now let's take a our time is up, but let's see how we can add a library, and let's use this particular wireless module as an example. So there's an NRF 24L01 wireless module, right? Wireless RF module, radio frequency module. So we attach one on our transmitter, one on our receiver. So you can use this one. You have I think you have two of them in your SIR kit, and so you have two of them in your SIR kit. And so once you receive it, you can be able to use it to build a drone. You put one on the remote, and then you put one on the actual drone, so that you can send the drone signals. You can push the push button switch. Okay, I think let's appreciate this. Let's go off video. All right, I think we're back. So if you want to build a drone like this one, if you want to build a drone like this, you have the drone here, you have the drone here, and you have the remote here. So you just put one of these NRF modules. Just put one of these on your remote, right? You just put one of these on your remote. And to build a remote, it's so simple. You just have to get a microcontroller like this, and you attach this to it. That's it. You're done. And then you write code onto it. What it should do, what the microcontroller should do when you push a joystick like this, when you push it back, forward, all of these things, and that's it. And then for the drone, you also have to have the same wireless. For the drone, you have to have the same wireless this NRF module on the drone, and then that's it. So now you can be able to communicate. I think to a range of I think this last time I checked, with an antenna, you can be able to communicate over very, very long distances, and then that's it. You can just put this on, and then your microcontroller. You can put this together with your microcontroller, and that's it. So once you get your SRI kit, there are so many things you can be able to do. There are so many projects you can be able to work on. But yeah, let's assume that we are not working. We are just working with this NRF module, right? We're working with this NRF module, and we do not want to write lots of code, right? Lots of engineers have already written code for us, right? That simplifies the use of this, right? So all we have to do is just search for a library that we can use to make our work easier working with the NRF module. So how do we find it? all we have to do here, we can find it in the Arduino, in the Arduino IDE here, right? Let's take these things off. Let's take these things off. All right. So now we're left with the setup part and then the loop part. All right. Now let's start from scratch. We want to work with this particular NRF module. Now we know that we need to use a library so that it makes our work easier, right? So that we do not have to by ourselves write a whole lot of code. No, want our work to be easier. All right. So all we have to do is just come to this part. I believe you can see this part here. It says library. It has something like books here. So it's like a normal library. So we just click on that. Just click on that, and then we have a search. We have a search. We have a search bar here where we can. That's where we type the name of the component we are working with. So if it's a GPS module, you can just type in GPS here. And you're going to get a whole lot of GPS. You're going to get a whole lot of GPS libraries, right? That can be used on. If you have a GPS module and you're using it to. Yeah. So we can see something here. You can see GPS, GLONASS, Galileo, GNSS, and we have other GPS modules here, cellular, GPS, MQTT. We have libraries in here, right? But yeah, we are using this RF module. We are using this NRF module. So let's type in NRF. Let's type in NRF, right? 24. That's the name. NRF 24L0L01. And then that's it. So let's give it a few seconds. It's just going to search for us. Otherwise, you can just go on to your web browser, right? So let's use the web browser option first, and let's see. But in the Arduino IDE, it makes if you do things in Arduino IDE, it makes everything simpler, right? And so we can just go into the Arduino. We can just go, but we can just go into the into a new tab like this, and then we search for NRF. I think I've searched for this before. NRF 24L01. Yeah, Arduino library, right? So you just type that in, and then you click enter. So after clicking on enter, we're going to scroll down, and then you're going to find that there are lots of people that have created libraries for this. But we're going once we go forward, at this point there's no need creating your own library, but you can create your own library. You just write the main code, and then I think there are two files when it comes to Arduino library. So we have the header. We have something called header file. That's the .h file, and that has all of your functions. The functions that are going to be used in the functions that are going to be used in the functions that are going to be used in the library, right? The library that you are designing. So you just write those functions, and then you have a second file, and that file contains the actual work that you're going to be doing in the library, right? The actual work. If there's going to be calculations and all of those things, if there are going to be some for loops that are doing some complex stuff, you write all of those complex stuff in the actual code, and then in the actual file. That's a .cpp file, C++ file. So you write low-level code, C++, raw C++ code to do all of those things, and then you write the functions in a .h file. So yeah, and then that together will give you will help you create a library. So if you're working on a very complex system, and you need to create your own library to do certain things, then you can be able to do it. But yeah, if you're working on a system where you want to use some microcontrollers, some other components, some modules like a real-time clock, a GPS model, a wireless control model. This is exactly how you do it. You just go onto so we can find one here. We have Arduino library list. So we can go onto this website, and then we'll find this particular library. You can download it like a file. It's just like downloading a photo from the internet onto your computer, right? So you just and then it's saying that after coming here, it's saying that it's on GitHub, and I believe everyone in here you know about GitHub. So we just click on the this NRF24. Yeah, we just click on the link, and then it brings us here, and then in here we can see in here it says the languages that were used to create this particular library: C++, Shell, Python, C, Rust. Right? These are the languages that were and then now we can be able to get information about this particular library here. that it can be used to control an NRF module. That's RF24. So you can just click on this one, right? And then we'll go into it, and then we can read about it. There are lots of information about it. So we have docs, we have examples, right? Like we mentioned, there are examples. So that the person that created this particular NRF library, he or she, or whether they are a team of people, they are going to just give you examples how to do it, the functions that are in there. And you can see here that there's a README file in here. There's a README file. README. It just means README. So you just have to read it in order to know to get very good information about it. Yeah. So it says README. So now we can scroll down. Okay, this is README. Okay. And library dot properties NRF24L01H. Okay, so we can just let's click on that. So yeah, so you just have to do some diligence, and then you just go through the library to know how things are done, right? Yeah. So here, so this is the actual low level code. This is the actual C++ code. Let's see if it's C++. Yeah, this C. Let's see, is it C++ or C code? The actual code that was written to create this particular library. So you can see that if you are not to use this particular library, a simple library that makes everything easier for you, and you are writing your own code, you would have written all of these long stuff, right? You're going to write all of these long stuff. But yeah, in the Arduino IDE, we can search for a library for this particular NRF module. And all we have to do is just come to this part here, library, and then we'll put in NRF here. And then now we can see so many options here. So there's one here that we can use. And different libraries have different ways of doing things. It's like when you come to Ghana, if it's like when you go to the Ashanti Kingdom, when you're greeting, you need to do something. When you go here, if you're greeting, you need to do something, right? Yeah. So if I create my own library, I can create my own functions. So the functions that I will be coming up with, even creating a function, you're going to give it a name, right? I may give my function a name of, let's say, send data. You can just create any function that is going to be doing the sending of data and the receiving of data, right? And then someone else may create a function, and then how things are going to be done. Yeah. So the main point is things are done differently, even though it's the same library that will be used to control this NRF module, right? So it's like those people, they know that it's difficult to work with this particular component. So they go through the hassle. They do the heavy lifting for us. They go through the hassle, and then they put up, they reduce the work for us, right? They write the low level code, all of those numerous code, and then they put it in functions, simple functions that we can use in just about 5 functions or 4 functions, right? 4 keywords that we can use and simplify our work. So yeah, there's one there's one module, there's one library, and there's another library here. There's another library here. We can see a library here. We can see the name. We can see NRF. Yeah, so this is the library I installed, right? This is the library, the NRF. So we can see NRF Lite, right? It's called NRF Lite. Yeah, and you can see installed, right? 3.0.6. That's the version of it, and then that's it. So once you go into it, you can see that it says more information here. It says more information, right? So once you click on it, it's going to take you to the GitHub of the person or the group of people that created this particular library, and then you're going to do some reading. You just have to read through the library. Give you examples how to use it, how to do this. If you are creating if you are using this particular component on the transmitter side, or on the receiver side. So you can see RX, right? And we can see TX, right? So this is a transmitter example, an example that for this. So you just say hash include SPI for serial peripheral interface communication, and then you include the library here. You say include NRF Lite. That's it. And then I actually have the code here. So you just read through. It's just about reading. You just read through, and it tells you how to use the library, right? And it makes your work easier. I actually have a code for it. I actually have the code here. I actually have the code here. Please give me a second. Please give me a second. All right, I think we are back. Thank you. So yeah, if you're working with if you're working with this particular wireless controlled module, you need to get a library. You need to install a library. You just have to come in here, the library that you prefer, right? And there's another library here, NRF Hall, right, by Nordic Semiconductor. So you can see by, and this particular one, the one I use for my project, it was made by someone called Dave Parson, right? NRF Lite by Dave Parson. So the keywords in here, the functions in here may be different from the functions in here. How to do things in here may be different from how to do things in here, right? That it's so simple. It's as simple as that. So you just have to include a library. So once you install it, once you click so let's take for instance, I want to install this particular one, and just click install. And after installing it, but well, I use this particular one for mine. So I can just come in here, and then let's click back on this, and then it will collapse, right? And then I can just click on sketch, and then click on include library. Once you install it, once you download and install it onto your computer, it's going to get shown here, right? It's just going to get shown here. So you just have to scroll down, and the name of the library that you installed is going to be appearing here. So we have the library I installed, the NRF one. It's called NRF Lite, right? So we can see it here. I believe everyone is able to see it here. We have NRF Lite. You can see that I also installed another one. It's called RF24, right? But we are not using that one. So if we're using that one, I can just click on it, and it's going to get included into my code. It's just going to be added into my code. Otherwise, if I'm using the NRF Lite one, I'll just click on it, and then that's it. It has included it in here, right? It's just going to type it in here automatically. So it's just going to say hash include NRF Lite.h. That's it. So simple. So yeah, that has included my library. And then since it has taken us to GitHub, we can read about this particular library, how to do things in the library, some of the functions in the library. So some of the functions in the library is init, right? Init. So init, right? Radio, you give it a name. So yeah, you just have to first you add your library. That's it. In hash include NRF Lite. Good. And then you create an object, right? So you just say NRF Lite, and then you give it a name. So in this particular example that these people that created a library they use is they created an object called underscore radio, right? That's the name of that's the special name they give. That's the object, right? And then they created a variable called data. They created a variable called data, and this thing we are seeing here on sign int, on sign 8-bit int, right? So this is just a data type. It's just like saying on sign int. It's just like writing on sign int or writing something like int. So do not get confused about this. So they just created a variable that is going to be storing the data, right? And then they came into the setup part of their code, and then they wrote init. They just wrote the name of the object, the special name that they gave to the object. They just wrote it here, radio.init, right? So there's a function that is found in the library, and it's used to initialize. Or start the NRF component if you connect it to your microcontroller, right? So you just say radio, the name that you give to it, .init, right? So if we're using two NRFs, and we can just give it a name of, let's say, transmitter NRF, right? We can just say NRF Lite transmitter NRF, and then from that particular point in time, whenever we are working with it, when we want to initialize it, we're going to say transmitter NRF .init. So .init, the .init here is just a function, and then it takes in these parameters. So let's see what are these parameters for. It says this particular part is set the radio to ID number 1, right? So the first number we put in here, it's just an ID we are given to the NRF, right? It's just an ID we are given to it, which is going to help it, identify whether this one is receiver, this one is transmitter, and if you have multiple NRFs in your system, just to identify them, you give it an ID number of 1. So that's the first parameter. And then the second parameter, let's see what's the second parameter, pin 9 and then a pin 10. I think these are, it says along with CE and CSN pins, right? Along with CE and CSN pins. And I think CE, what's the meaning of CE? Um, I think it may have escaped me, but we can just, there's nothing you should keep in your head. You can just look this up. On an NRF, when you say CE, what's the meaning? When you say CSN, what's the meaning? I think there's chip enable, something like that, or chip and CSN is chip select not, something like that. I remember. I think something like that. CE is chip enable, and then CSN. So just these are pins on the NRF, right? So you just have to put the ID of the NRF, that's ID1, and then the pin numbers. So if you connected CE, the pin CE on the NRF to pin, let's say to pin 5 of your Arduino microcontroller, all you have to do is just write the pin number here, pin 5. And then if you connected CSN pin to pin 10, you just have to. So working with a library is not so difficult, right? You just have to read through it. The people that created the library, they're going to give you examples. They're going to give you examples on how to use the library, some of the functions that are in the library. So, figure it out. So that's it. That's it. It's just about figuring things out. So that's a good education, right? You don't have to recite the multiplication timetable. No, you just have to know the concept, and that's it. Any question, any problem someone gives you, you're able to solve it. So that's it. And since you know how to read, that's it. That's the main thing. But yeah, lastly, there's another function here called send. And then the send function, it takes in, so all you have to say is the name of the NRF. So in our case, we said this is the first NRF, right? Oh, this is the transmitter NRF. So we just say transmitter NRF dot send. And this is this is the function that is used to send data wirelessly from this NRF to another NRF. So we're using two NRFs and this transmitter on our drone's remote, and then this is the transmitter on the drone's on the drone's body, the receiver. All we have to do is, if you want to send the remote, if you have a drone remote and then we push the joystick forward, it's going to generate some joystick data, some analog data. The joystick is just potentiometers in there, right? But yeah, you're going to appreciate all of these things as we get into our practical sessions. But yeah, so if you want to work with a library, you need to just read through it, and then you know how to use or how to go about things. There's a function that will help you send the data to the receiver, from transmitter to receiver. So it just says radio.send, or the name of the specific name you give to your object. In our case, we just said transmitter NRF.send, and then you have bracket open and bracket close. And in the bracket open and bracket close, you put a first parameter in here, and let's see what's the meaning of that first parameter. Send data to the radio with ID 0, right? So you give the transmitter an ID, right? This is the receiver. You give the receiver an ID of the receiver has an ID of 0, and then the transmitter has an ID of an ID of 1. So if you want the receiver to, we're going to appreciate all of these things. But yeah, this simply how a library is. Whenever you want to work with components, whenever you want to work with electronic components, if you do not want to write so much code, if you do not want to write long code, all you have to do is just work with a library, and that is going to make your work easier. A library will make our work easier, right? You just have to go into your Arduino like this. Just go into the library part, just search for the library you're using. So you type in the component you're using, and then you're going to find a library that someone has designed, and you just install it. You just click on install, and then you can see that for the one that we clicked on, it has installed. It has given us a message on the output of our Arduino IDE. It says downloading NRF core, and then it says installing, and then it says install. So it's like a file. It has downloaded a file onto your computer. So if we're not using the Arduino IDE here, we could have just, like we mentioned, go onto the web browser, search for it, and then someone has designed it in their GitHub. They have stored a file on GitHub. So we just go on GitHub and then we download it, or we clone it. Yes, we just download the file, and then we import the file into the Arduino IDE, and we're able to install it, right? But yeah, in the Arduino IDE, it makes everything easier. You just search for the component, you get a library, and then you install it. After installing, it says install. It gives you a message, a happy message here. And then if you want to install this, you want to include this particular library in here, you just have to go to sketch and go to include library. And now we can scroll down here and we'll be able to find the library that we just installed. Yeah. So I believe everyone can see it here. You can see NRF Hall. I believe everyone can see it. NRF Hall. So if you want to include that particular NRF and not use the previous one, just click on NRF Hall. That's it. And you can see it here. It has been included. So it says include NRF Hall.h, right? And if you want to know more about this particular NRF, right, the functions in there, how to do things using this NRF, all we have to do is just scroll down, right? Oh, we have taken it off. But yeah, we could go there, NRF 24L01. Yeah, so we could find more information. You can just click on it and it will take us to the GitHub, the source of the library, and then we just click on more information and then we read on the library and then we know how to use it. So simple. It's going to tell us how to do things. It's even going to give us examples how to do things. Okay, so we have NRF. Yeah, so there's it, NRF all, right, installed. So you can click on more information. Right after you click on more information, it's just going to open a tab on our computer here, a tab on our browser, and yeah, it's taking us to, so opens, yeah, GitHub has opened. So now it just tells, it's just like you buy something from, you just buy something, a TV, and then it gives you a manual. It just gives you a paper that guides you on whether you should connect the positive to this or the negative to that, right? That's just a library. So we can just click on examples. Once we click on examples here, it's going to give us some of how to use the library itself. So NRF RX, so receiver, an example code that can be uploaded onto your receiver microcontroller. So here is it. You can just click on it and it's going to open for us. So yeah, so so there's the example code, and we can see the type of commenting that he has done here. So he said copyright these things. This is software distributed without any warranty and all of those stuff. Yeah, and it says that the code, you just have to include serial peripheral interface, because this particular module here, it communicates with microcontrollers via I2C. It communicates via I2C. So there is SDA on there. There is SCL. These two pins, serial data, serial clock. You can find serial data and serial clock on this one. No, this SPI. No, SPI uses four pins. So we have MOSI, pin, we have MISO pin, we have chip select or CS or reset, right? And then we have, finally we have, what else do we have? Finally we have MOSI, MISO, chip select or slave select or reset, and then finally we have serial clock, yeah, SCK. So there are those 4 pins on there. So you just connect it to your microcontroller, and then that's it, right? Together with the other pins, yeah, and then that's it. So this is how it's supposed to. So you can see that there are some libraries are, some libraries make the work very, very easier. Some also have lots of stuff that you need to do, right? So you just have to look, just have to search for the right library to use, the right library that is suitable for you, that will be good for your particular project, and that's it. But I believe you've made some good progress. So in today's session, we took a look at libraries, and libraries is so simple. Libraries is just library is just a piece of code, a file that has some code in there, and it helps make our work easier. So if you are building a car, you don't have to build your own tires. You don't have to open up a new factory that is going to be manufacturing the tires. Otherwise, it's going to take 15 years for you to come up with the tires. If you are creating an electric car and you need to buy a battery, just buy it from a company and then use it. Plug it into your computer, into your system. Don't try to create a new battery from scratch. No, you don't have to waste time doing that. So that's like a library. And past questions. So he just the teacher just goes for a past questions book, and then he takes the questions from there and he puts it together and then he gives it to his students to answer. So that's it. So simple. So for libraries, whenever we are working with components, electronic components, we need libraries to simplify our work. Otherwise, we're going to be writing lots of code that are unnecessary, lots of low-level code, right? We're going to write our own loops that are going to be doing a whole lot of stuff, and it's going to just increase the time. It's just going to, we're just going to waste time, right? Yeah. So that's library, and for a library, there are functions in it. There are certain keywords in it. How to use it? You just initialize. You just add the library in here, and then you create an object. You create an object. You give it a special name of your particular component. If this is the first component, the second component, you just write it. Just give it a special name, and then for some libraries, you have to initialize it, right? Like we saw, on there, you can see wire.init, right? And then you put the pin numbers in there, and then it's going to just start the library, or just start the communication between the microcontroller and this one. But yeah, we're going to be taking a look at all of these things. But yeah, so that's it. That's libraries. So for now, you've made some very, very good progress. This is just everything about microcontroller programming. If you want to build a system, all you have to know is variables and data types, conditional statements so that you can make decisions, loops so that you can say, okay, this thing should do how many times, right? And then after learning about loops, you learn about functions, how you can create your own functions that are going to be returning answers to you, functions that are going to be giving you feedback, right? That's it. And then built-in Arduino functions that are actually used, that have been created, special functions that have been created by Arduino so that you can turn some things on. You can send some signals onto input output pins. You can do some timing. You can do some calculations, some square root. You can do square root. You can do squared, 2 squared. You can do all of those math stuff, right? So timing, math stuff. You can write signals into, and you can read also signals. So those are functions. And then after functions, you have libraries. Libraries is a big boss. Library is just a piece of code. It's just a whole lot of code that have been written together into a file, and then you can just download the file and then import it into your computer, onto your Arduino IDE. And those libraries are used for components. So if you're working with a servo motor and you want to quickly write code, you don't want to write a whole lot of code. You don't want to waste time writing 50 pages of code. You just have to add the library, and the library already has some code written in for you, and you just have to use their functions that have been created in there. Then you can just write just one line of code, and you can control this. Meanwhile, if you were not using a library, you would have just written a whole lot of code, right? So that's libraries. So usually we also use libraries for LCDs, for displays. So if you have a display, if you are building a system and there needs to be something like a display on it, I think you can appreciate this. We are done with the session. Let's take a look at this. Let's take a look at this. I to see display. Yeah, I to see display. Yeah, I squared C LCD. Let's see. We're going to be appreciating some of the images in here. So if you're working with OLED, let's go from OLED display. Let's search for OLED display. Yeah, but that's a very simple one. If you're working with an LCD display like this one, where you want things to display on the screen, these components also have libraries so that it becomes easier when you want to work with them. And OLED displays. Let's type in here OLED display. OLED display. Yeah, OLED display Arduino. Yeah, and then let's take a look at some images. So if you're building a very tiny system and you're going to be using a display like this one, all of these components like this, they require that you use a library. There's some code that have been written into a file, and it makes your work easier, right? So you just download and install the library onto your Arduino IDE, and you're able to do all of these wonderful stuff, right? You can build your product and then you put this on there so that users can be able to see the battery percentage, all of those things on there. And it's so simple. So these are just the 5 things: variables and data types, conditional statements, loops, functions and libraries. So that's it. You've made good progress. From now, you do not consider yourself a beginner anymore. I think this brings us to the end of today's session. But before that, give me a thumbs up if you are good so far. Otherwise, if you have a question, please raise your hand, and you can be free to ask. Do we have any questions? Do you have any question? Okay, looks like this is not sharing. Okay, Felix, are you good? Give me a thumbs up. Everyone, give me a thumbs up if you're good. Roddy, are you good? Herbert, are you good? Isaac, Michael Okuti. So when you mention programming microcontrollers, no matter how complex the system we are building is, no matter how simple it is, these are just the five things in programming, yeah, in programming electronics. These are just the five things. And from now, what is important is working on projects so that you appreciate, you get to use what you've learned on loops. You get to use what you've learned on conditional statement, if else. You get to write loops. You get to write your own functions, right? So yeah, some projects will not even require you to write functions. Sometimes it's just simple stuff. Some simple project will just but some other difficult projects or very complex projects will require that you use these stuff, right? But yeah, I believe you've made some good progress from our next sessions from session 25. We're going to be going back into electronics, and we're going to be taking a look at transistors. We're going to be learning practically about transistors and resistors, something called voltage divider, so that you can keep track of your battery percentage. Now that we know about microcontroller programming, if you are using any component that we need to write code on and then read signals from them, now you can be able to understand when you write the code. So now you're going to be appreciating all of these things really, really well. And I think from after today's session, I think we've made this announcement so many times, but you've not yet received the account number. But you're going to be receiving the account number where you're going to be sending your SRR kits, your money to. You're going to receive an account where you're going to be sending your money to, so that you're able to get your SRR kit. And you're going to have all of those components in the resistors and these things in there. And for those of you who were not in yesterday's session, there was an announcement that we're going to get an extension, so that everyone in here, you make some very good progress, so that you can get your SRR kit, and then we can make some good progress. You can build a drone by just using the programming stuff that we've learned, the electronic stuff that we are learning. You can use the components in the kit, and then you make some very practical progress. Oh, already, yeah. Just asking. I thought you should have known by now. The price of the SRR kit, the simplified introduction to robotics kit, was in the contract document you signed. It was just 999 CDs. It has all of these good. I believe we can see a 3D printer behind me. Can we see a 3D printer behind me? These 3D printers have very good stepper mode. Okay, you're unable to see, but yeah, you're going to be appreciating this as you go forward when you're working on our own when you're doing 3D printing. So we have actual stepper motors that are used in products like this. We're going to have them in the SIR kit, and you can use that to build actual systems. And when you buy this, when you buy this particular kit with all of these components, resistors in there, I believe some of you are in level 300, going into level 300, level 400. When you get into building your final year projects and all of these, so this is just a very, very good investment that you're going to be making. 999 CDs with all of these components. For resistors, you're going to have a whole lot of values for the resistors, for capacitors, for transistors, a whole lot of different values of transistors, for the NRF module. Some school projects will not even require you to use this, but for you to be able to build actual systems that work, actual products, you need to learn all of these stuff. And so all of those things are found in the SRR kit. And I believe everyone in here, you have your document. And so once we go off the session, go back to refer back to your document, and you're going to see everything that is found in the kit. And you're going to, get the price and everything. But it's 999 CDs, just 999 CDs for but yeah, go back to the document, take a look at the components in there, and you're going to find that so for just an ESP32 board like this, there's an ESP32 microcontroller in there. There are shops here in Ghana that sell this for around 139 CDs. But in a kit, because of our partnership, because of our strategic, procurement of these components for you, you get it around 50 CDs, just around 50 CDs. So these actual components that work, these actual hardware components that are used in systems that people buy in actual products, they are quite expensive. But you have gotten, because of the strategic, you've gotten it at just 50. Well, this quite everyone knows about this, an ESP32 board or an Arduino board. But yeah, the prices in there are so cheap, so that you can be able to afford all of these high quality stuff and not use the usual Arduino kits. Those kits, those little Arduino kits, they have four components in them. An example is this stepper motor. This stepper motor is not found in any product. It's not found in any product in this world that exists. You can't find any product in this world that uses, you can't find a company that produces a product using this stepper motor. No, it's just using Arduino kit so that students who are learning about programming will just know how to control the stepper motor. But it's not used in actual product development. But the kits in your SIR kits, it's a bigger motor, a bigger stepper motor that is used in a 3D printer, an actual 3D printer. And so you get to use these industry grade components at just that very, very good price. If you're buying the component single, one by one, they would cost way, way more. And so just do yourself a great favor, do yourself a very good investment, and then buy this. You're going to be using it throughout your entire robotics journey, right? So I believe that's a very, very good investment. Yeah, you're going to be making. But yeah, as our time is too spent, very, very fast spent. And so let's bring today's session to a close. In light of no questions, do we have any more questions? I believe you're good. Ready? I believe you're good. All right, that's great. Michael, I believe you're good. Abdul Salam, I believe you're good. Felix, Isaac, I believe you're all good. All right, all right. And if any of you didn't really get anything on the programming, on loops or anything, you can just text me and on WhatsApp, and I may be able to connect with you one of these days throughout the week for the shipping fee. Oh, yes. For the shipping fee, it's just, once we have the kits in, we usually, we give it to a car, right? And then you get the driver's number, and then he just delivers it to you. And then once he gets there, just pay for it, right? So usually, if you are here in Takrady, you can just get, that's because you are here in Takrady, so you can just quickly get it. But if you're in Kumasi, if you're in Accra, you just have to just pay a little bit for the shipping fee. Just pay the driver, and then he delivers it to you. That's it. So simple. But yeah, I believe we're all good. If you do not understand anything on the programming, feel free to reach out to me throughout the week, and I may just schedule about a 30 minutes session with you privately, and then just so that you understand something. Otherwise, do not worry about anything. Once we are working with components, once we are working with the hardware components in a kit, trust me, all of these things that we have discussed, you're going to appreciate them. They are so simple. All right. Enough of the talking. Let's all have a very good night. Bye everyone. Bye. I'm going to be connecting next week Saturday. Bye.